We are on the section 8.1 and 8.2, page 22. This section, we are going to talk about rational expressions and multiply and divide those expressions. Okay. So every time we use some names, symbols, we always explain what they are first, right? And vocabularies. So how we are going to make a meaning of it, right? So let's review something first, since we use the term called rational, right? Then we learn those things before, like something called rational numbers. So let's talk about numbers first before we talk about expressions. Expressions are algebra language, okay? So let's talk about rational numbers first. So a rational number is a number can be written as what? Rational. Rational. It's like a ratio. It's a ratio of what? Two integers. So ratios are written as this way, A over B, right? So to be rational, it means what? To be reasonable, and reasonable numbers are those things like fractions, okay, part of a whole. Okay, so A and B are integers. Then for fractions, you have a restriction. Denominator cannot be 0. So those are numbers we talked about before. Rational, something called rational numbers means it's a fraction, right? And algebraic expression are what? Math language, right? So for an algebraic expression, we talked about before, is a math language which includes what? Those have numbers, right? And or variables. So combination of numbers, variables, right? Then we talk about those represent the math idea. And also we do what? Add, subtract, and multiply, and divide together to express an idea for math. So we express the math idea, then that's math language. And we say a rational expression is what? That would be rational style, means a fraction style, but with math expression. So that would be what? A ratio of two right? Polynomials. And polynomial is written as what? A fraction style, P over Q, and both P, Q are polynomials, right? Polys, then denominator cannot be 0. And we also talk about something called functions, okay? So if we say a rational function, what are we talking about? Something rational, right? So we write it as what? Function style, f of x. Then function equals a what? A rational expression. Those are the terms we are going to use. So we are going to start from, basic skills. So for rational numbers, the basic skills are, right? Rational number for fractions. And basic skills we have learned are what? We always do what? Simplifying, right? Simplify. And add, subtract, and multiply, and divide, right? That's for numbers. Then we are going to learn something called rational expressions, and is what? Polynomials with fraction style. And for those things, the basic skills, what do you think we are going to learn? Same thing. Simplify, right? And add, subtract, and multiply, and divide. So that's things we are going to do. Then we are going to do multiplication and division first. Okay? So, before we start those basic skills, we are going to talk about something called evaluating and finding the domain of a rational function. So we say rational function is what? You are writing a function style, okay, with a rational expression with it. So things like this, and looks like this way, okay? Looks like this way. If I say f of x, that means f of x actually is your y, right? So function is what? The things you go from A to B, you go from x to y. So from x to y, then y is writing as your function style, f of x. Okay, so it will look like this. So if I have a function style, the y, which is equals to 5x minus 6, then it's like a rational numbers, fraction style, right? Then we call it what? Rational function. Then we are going to talk about domain and its value. So in general, for a function, we are going to talk about domain and value. Okay, domain we talked about in your 152A class before. So domain is what? All possible x values. Okay, then your value is your range, means what? Y values. Means what? All possible y values. So let's just review the notations again. We are written this way, f of x, right? Whatever x is, you get your y. So for this one, what's your domain? What's the possible x values? So you do your t-table, you plug in your x value. Do you think you can plug in anything for x? There's no restriction for x, right? So x, it can be anything. That means x is what? All real numbers or any real numbers. Okay? If we ask you to find the f of 3, what does that mean? That means when x is 3, what's your y value? That's what it's asking. So you just plug in. So what do you have? 5 times 3 squared minus 3 negative 6. The value will be 45. Okay, would be 7. So that would be the answer for the symbol f of 3. That's what it means. Okay? And look at the next one. If we have this one, that's your example 1, example 2. Say find the f of x for this function. 5x squared minus 3, x plus 2, right? So we say find the domain. What does that mean? To find all possible x values, when you do the t-table, then what kind of things you can plug in for x? You can see x can be what? Anything, right? X is any real number, but except what? You cannot use. Except negative 2, right? Why negative 2? Because when you put a negative 2 there, you will make the denominator 0. And we say for a fraction, you cannot use 0 as denominator, right? If we ask you what is f of a negative 2, so you plug in, right? Then you make a denominator 0. And here 2 squared, 4, 20, 17. Can we do that? No. So you can say, okay, because the denominator is 0, so usually we say undefined or doesn't exist. Either way is fine. So what are we doing? We are doing what? Rational expressions, but put it into the function style. So we call it what? Rational function. Rational function. Then when we talk about rational function, right? We are talking about what kind of things we can use for x. Then what kind of result is the y, which is f of x. So we want to find out what's the domain. That means all possible values means what? What kind of x we can use for the function. Because they are what? Fractions. So we need to be concerned about what kind of x we can use. If just, polynomials, you can plug in any number you like, right? Polynomials, you can plug in any numbers here, but not fraction types of poly, right? Because there will be what? Restrictions. So look at this one. Next one, if my f of x is 7x minus 2 over x squared minus 2x, right? So do I have a rational function? Right. So you can plug in x, so your domain is x is any real number except what? Except that those numbers will make the denominator 0. So you need to figure out what kind of things will make the denominator 0, right? So that will be make things like this, denominator 0. Then how do you find the denominator? which number will make it become 0, right? So what do you think, how to find it? So what kind of equations do we have here? Do we have a quadratic equation? Right? So how do you find it? Make it 0. You factor it. Leading coefficient is 1, so you can just find a number. Right? Then 5 times 3, negative 15, added together is negative 2. Then you use zero product property. So x is 5, x is negative 3. So we find out if we use 5 or negative 3, they will make what? The denominator 0. Can we do that? We can't. So we cannot use these two numbers. So one is 5, one is negative 3. So the domain, the restriction for the domain is what? You can use any number except the restrictions, which is what? 5 and negative 3. Okay? Okay, for rational expressions, we are going to do some basic stuff. So, like simplifying, add, subtract, multiply, and divide, right? So, let's do some simplifying first. So, we are talking about what? Rational things, rational numbers, or rational expressions. And for numbers, rational numbers mean what? Fractions, right? So for fractions, and to simplify a fraction means what? You will do it writing in lowest term. Write it in lowest terms. Right? For numbers, we will do that. But the same thing for the expressions, we will do the same thing to write in lowest terms. So, like we did those before, right? It's a fraction. How should we simplify? So 5 can go into both, so you do that. So that would be 13, right? Divided by 3. So that would be the answer. That's one method we used before. Another method is this way. We will figure out what kind of things go into 15. So you do your trees will be what? 3 and 5. 3 and 5, right? Then you factor 65, and that will be what? 5 and 13. So 5 times 13 would be 65. So if we do that, we can cross cancel the 5. Then what do we have? We have 3/13, right? So do we have same answer? Yes. For numbers, we can do either way, right? That's first method. That's the second method we will use. However, for the rational expressions for algebra, then it's a little bit different than the numbers because we don't know what kind of things can directly go into both. So we need to do what? Second method. So the method would be following this way, right? So we will do what? So for step 1, we will do what? You will factor the numerator, right? Numerator and the denominator right? Completely. What does completely mean? You know that, right? We did it from exam 1. We ask you, what does completely mean for factoring? It means what? 2 primes, right? To the little tiny parts, the smallest units. And step 2, what do? We will just cancel out the common factors, right? So you divide the common factors this way. So look at your page 23. Okay, so let's try some examples. So here on the top, the steps is the same thing. Factor the numerator, denominator completely instead of to prime numbers, you will do it to what? To prime polynomials, right? To all the prime polynomials. Then you cancel out the common factors. So same steps, right? Let's see some examples. So for first one, so first you check. Is this a prime? Yes, that's the simplest form, right? Then for the denominator, is that a prime? Binomial. It's not, because you have what? GCF to factor out. So 2 and what? X squared, x cubed, that would be x squared. So you take out that, you will have what? 5x, right? And minus 1. Then you cancel out those. So that would be your simplest form. So we are doing what? Rational expressions. It's a fraction. So for any fraction, we always do what? Write it in a simplest form, right? Same thing for rational expressions. For number 2, 2 plus x, x plus 2, right? So we always write the things what? In standard form. So what we do is actually 2 plus x, x plus 2, you know they are the same, right? 2 plus 5 is the same thing as 5 plus 2. But we will write it in standard form. That means what? From higher order to the lower one, right? If so, then top, the numerator is what? Binomial. Same thing as for denominator. So for this binomial, can you simplify more? Not really. That's the simplest form. So that's a prime. Put the parentheses around it, right? You cannot just kill part of it. It's just like you say, okay, 52 divided by 32. Can you just cancel out the 2? No, because they are not multiplying. When you cancel out things, you have to be what? A group things. And cancel out. By multiplying together, you can cancel out the same thing. Okay? You cannot say, okay, x plus 2, x minus 3. So you cancel out the x. Don't do that, okay? Don't do that. Because you cannot cancel out part of things. You only can cancel out things they are multiplying. So you cancel out things means what? Dividing, right? That's called simplifying. You divide things, then make it simpler. Okay? You cannot cancel out part of the group because the line dividing means group on the top, group on the bottom. Now, because x plus 2 is a group, same group, you can cancel out this way. That would be 1. Okay? You often make mistakes like those. Don't do that. So next one, 2 minus x and x minus 2. Are they look alike? Pretty much, but not exact, right? So when we simplify this, and first, if you just write it in standard form, right? That would be negative x plus 2 because the sign goes with the thing behind it, right? The sign belongs to the variable or the number behind it. Then if the first number, you always what? If it's a positive, you don't have to have a sign. So that 2 means what? Positive. So you rewrite it, you carry the sign over with it. So negative x plus 2. Here would be x minus 2. Then what do we do with that? Usually negative start from negative. We would take a negative out, means negative 1 out, right? That would be x. Everybody change the sign, right? Then that would be x minus 2. That's a prime, put the parentheses around, right? So now you can cancel out. So the answer is negative 1. Okay? You have to get used to this way to write it in standard form. Then if you take a factor, the negative out, then inside the parentheses will always start from what? Positive x. So this way you can compare them if they are very close, if they are the same or not, because you start from same sign. That would be much easier for you to cross cancel them. Right? Okay, let's look next one. So to simplify means what? To write in lowest terms. Then for the rational expressions, then we factor them out, then cross cancel the same thing, right? When they are multiplying together. Let's look at the next one. So, 2 terms. Is that prime or not? But before you decide whether or not they are primes, you should write it in what? Standard form first. Right? Then now we look at the top binomial. What should we do first to factor it to the what? Lowest terms. Right? So you always take out what first? GCF. Start from negative, you will put a negative out. So that will be x squared. 18 divided by negative 2 will be minus 9. Right? The bottom is what? How many terms? 3 terms. A trinomial. How should we break down the trinomial? AC method, right? But this one is leading coefficient is what? 1. So you can just put x and x here. Find the 2 numbers, that work. Minus, multiply together is -3, added together is -2. So which two numbers will work? That will be -3 and 1, right? Multiply together, -3, added together, -2. Then check. Those are primes. On the top is x squared minus 9 a prime? Binomial. Not really, because it is what? The difference of two squares, right? Then a squared minus b squared, it should be what? A plus b times a minus b, right? So this one will be x squared, this one will be 3 squared, right? So you should have what? X plus 3, x minus 3, right? Then we have this on the bottom. So, can we cross cancel those? Yes, because they are multiplying form, right? Then the answer would be simplified form would be like this. Okay? Or you can multiply them out, becomes what? -2x minus 6 over x plus 1. It's not quite recommended, right? Because usually we leave them in prime forms because you can see whether or not you need to simplify more, right? Next one, we have x cubed plus 8, 2 plus x, right? So the top one, can you break down more? Yes, we say what? The sum of two cubes, right? So the sum of two cubes, what's the formula? It should be what? 2 terms here, 3 terms there. Plus here, right? Then next 3 terms, first will be opposite sign. Last one is a positive, right? And so this one is a cube for the a, cube for the b. So that will be a plus b, right? The 3 terms will be a squared minus what? A times b and b squared, right? So that's the formula for the sum of two cubes. If it's a minus, here will be minus, here will be plus, here still plus. Remember your formulas? The sum of two cubes, or the difference of two cubes. So for this one, x cubed plus 8. Is 8 a cube? Yes, that's 2 of the cube for the 2. So you will follow the formula. So that would be what? X plus 2, right? And this one will be x squared, first square, and minus 2 things multiplying together. 2 times x, 2x. Plus the second thing, take a square, so that would be 4. Right? The bottom one, 2 plus x, is the same thing as x plus 2. Is that a prime for x plus 2? Yes. So you do that, right? Put a parenthesis around it. Now you can cross cancel those. So your answer should be what? X squared minus 2x plus 4. Right? What are we doing? What are we learning? We are learning something called rational expressions. Then we are going to do the operations on it. So first is what? Simplifying. Simplify. Then add, subtract, multiply, and divide. Right? For number 5. So, first we break down everything to primes. Then we cross cancel, right? For the top, binomial, and we will always do what first? GCF, which is 2. That's what we have, right? For the bottom one, what should we do? 4 terms. So 4 terms, if trinomial, 3 terms, you will do what? Easy method. 4 terms, usually we will try what? Grouping. So grouping that. Then for this group, you have y squared as GCF. Then you have y minus 5, right? For next one, you don't have any GCF. That means GCF is what? 1. Positive 1, y minus 5, right? Then for these 2 groups, you have what's in common? Y minus 5, so you have y squared plus 1. Right? So we break down as y squared plus 1 and y minus 5. Can we break down more? Y squared plus 1 is what? It's a prime. We say a squared minus b squared. The difference of 2 squares you can break down as such, right? When you multiply out middle part, it's canceled. So end up a squared minus b squared. Then we say a squared plus b squared is what? A prime poly. Right? Polynomial. You cannot break down anymore. Because 2 terms multiply together, simplest one is a squared minus b squared. Or 2 terms times 2 terms, binomial times binomial, sometimes is what? Trinomials. Okay? So if a squared plus b squared, the sum of 2 terms, sum of 2 squares is a prime. So you cannot break down anymore, but you can cross cancel for that. So the final answer will be 2 over y minus 5. Are we good? Okay, let's do some multiplication and division for fractions, all right, of polynomials. So first, let's check what did we do on what we did on multiplication and division of fractions for numbers first. So let's kind of review the numbers first. If 6, 7 times 14 and 15, right? So method 1 is what? Method 1, we did the old way would be what? You cross cancel. 7 and 14 would be 2. And 6 and 15 can be divided by 3. That would be 2 and 3. Right? Then after it's done, oops, not divided by 3, not 3. It's 5 here. right? Then we multiply straight across, that would be 4/5, right? Now we do this way. So we can break things down to the lowest level, lowest term. For numbers, lowest terms mean what? Prime numbers. So 6 would be 2 times 3, right? 7 is 7. Then 14 would be what? 2 times 7. And 15 would be what? 3 times 5, right? You just do your trees. Then, because they are all multiplying, so we can cross cancel those. And 7 and 7, right? Then we multiply straight cross, that would be 2, 2, and 7. Do we have same answer? So for numbers, we can do either way. But for algebra, for the rational expressions, we need to do the second method, right? So for multiplying rational expressions, just like the numbers, so what do? We write down the steps. So first, we will do what? You will factor them out, right? Factor the numerators and denominators. What? Completely, right? So what does completely means? To all the prime polynomials, right? Then, like those, then what do? We will cross cancel those if you have them in common, right? If possible. Then what do? After we cross cancel them, right? Then you multiply numerators and multiply what? Your denominators, right? That means what? Multiply them straight across. Then that will be your answer in simplest form as well, right? Because you already crossed out all the same factors. So you already simplified already. Okay, so that's how we do multiplications. Then how about the division? So let's look the next example. Let's start from numbers again, right? We do the division. So we say for fractions, how do we do division? Then we do change division to multiplication and do the reciprocal, right? Multiply is a reciprocal, is 3 and 3/2. And for 5, what do you need to do? You need to put the 1 underneath so you can multiply straight across, right? So that would be 15/2. I think that would be your simplest form. Or you can change to mixed number. That would be 7.5. Okay? But we don't do that anymore because we prefer, it's okay, right? But we don't use mixed number anymore. It looks like multiplication. So we usually use what? Improper fractions. Because you have to multiply, you have to divide. You always change the improper fractions to, change the mixed numbers to improper fractions, right? That's how we operate. So we just use improper fractions instead for numbers, okay? Then for rational expressions, polys in the fraction form, we would do the same thing for division and same thing for the multiplication as numbers. Okay? So let's see some examples for the multiplication. So if 7x squared 5y times 3y squared over 14x squared. Okay, that's on your page 24 on the top. So factor numerators and denominators completely. So you check. Is this a prime? Yes, because that's the simplest form when they multiply together. X squared, just shorthand writing, but that's just one term, right? So all those are one term. So what should we do? We can just do the cross cancels, right? So let's take a look for those. Anything you can cross cancel? So numbers and numbers. So what do we have there? 7 and 14. So that would be -1, that would be 2, right? And how about x's? So x squared and x squared, right? 3 and 5, you cannot do it. Y squared and y, you can get rid of one of them. You have 1y left. So you cross-canceled everything you can. And after that, you multiply straight cross, right? So that would be -3y, right? Here would be 5 and 2. That would be 10. Uh-oh. Am I right? Oh, I see. I was just checking the answer. So the problem was not the square. It was what? Fifth. Okay? So if you have fifth there, you cross cancel 1y, you should have a fourth. Right? So if a fourth, the answer should be fourth power. Right? Okay, let's see. Next one, 3x plus 3 over 5x minus 5x squared times 2x squared plus x minus 3, 4x squared minus 9, right? So before we factor them, we say you better write in what kind of form? Standard form. That way, inside the parentheses will always be positive to start with, right? So this is a standard form. This one you write a standard form will be what? Higher order to the lower order. So plus 5x, right? Times 2x squared plus x minus 3, 4x squared minus 9. Is that right? Okay, then we factor them, right? So is this a prime? Not quite, because you have GCF you can take out, right? For the denominator, you have 5, start from negative, so you have -5. And x squared and x, you have x, right? So after that, you take -5x out, you have x left. This one 5x, you take -5x out, divided by -5x, that would be -1, right? n times this one. This is a trinomial. Trinomial, and the leading coefficient is now 1, so what do we need to do? We need to do AC method. You should know AC method by now, right? If you still have some problems, you better practice more, because this class is based on that. Then you will have problem later on. So you need to do a lot of practice on factoring the trinomial. So I will not do it. You need to do it yourself. Okay? So x times 2x is 2x squared. Negative 1 times 3 is negative 3. The middle term times this is negative 2x. Then times this is 3x. Combine like terms, you will have x. Then for the denominator, binomial. A binomial, can we break down? Yes, because it's a minus in between, and those are perfect squares, right? So a squared minus b squared equals what? A plus b times a minus b, right? So that's 2x squared, and this is 3 squared, right? So you have 2x here. Oh, 1 is minus, 1 is plus. We have 2x here, you have 3 here, right? Now, do we have prime forms for everyone? And they are all multiplying together. So we can cross cancel x minus 1. What else? 2x plus 3, right? Anything else? That's it. So what do we have? Then we will have 3x plus 1 on the top, negative 5x and 2x minus 3 in the denominator, right? But if you leave the answer this way, the computer will reject. Why? Because we don't leave negative in the denominator, because denominator always reserved for the LCD, right? So we don't leave the negative there. You either move to the top or move to the outside. So you will write the answer this way. Negative 3 plus 1 divided by 5x, 2x minus 3, okay? Or you can leave outside 3x plus 1, 5x, 2x minus 3. Either one would be fine. Computer will take it. And if you put a negative on the bottom, I think the computer will reject it. Okay? So that's the multiplication. Okay? Then for the division, what do you think we need to do? Just like your numbers, we need to what? To multiply by its reciprocal, right? Just like your numbers. For the division, you multiply its reciprocal. Okay? So let's see some examples. So you would do the rational expressions just like you do the numbers. Because we say for rational expressions, it's a bunch of letters, right? In fraction form. And we say what? Letters mean numbers. So they operate in the same way. Okay, so let's see. We do the division. So 3x cubed y7 40 divided by 4x cubed y squared, right? So we say the method is what? Multiply by its reciprocal. So first you will change the division to multiplication and you do the reciprocal for the number after it, right? Then what do we do? Simplest form, prime, 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 prime. Simplest form, one term, all monomials. So we cleaned up by cross canceling. So x cubed go away. Anything else? Y7, they are both on the top. So that's it. Then we multiply straight cross, right? 3 and how many y? 7 and 2, total 9. 40 times 4 is what? 16. Is that right? Okay. Let's see one more. Number 2, that would be x squared minus 4 divided by 2x plus 6 divided by 2 minus x squared plus 4x plus 3, right? Before we factor them, we say we need to write it in what? Standard form first. Always write it in standard form before you factor the poly, right? And divided this one, you will switch around next. Negative x plus 2, right? Then we say you multiply by its reciprocal. So the first term, first fraction, it remains the same. Then next one, you will do the reciprocal, right? Then it's multiplication. We did as we did before. Then we start to break it down to primes completely. So for the first one, is that a difference of 2 squares? Yes. So x squared and 2 squared. So you have what? X and x, 2 and 2. One is plus, one is minus. Then for the bottom binomial, you have GCF, right? So that will be what? X plus 3, right? Then for this one, trinomial, what do we need to do? Leading coefficient is 1, you can just do XX, right? Multiply together is 3, added together is 4. Which number will work? That will be 3 and 1. 3 times 1 is 3, 3 plus 1 is 4, 3 and 1. Then for the bottom binomial, what do we need to do? We will take what out? Negative, because the leading one is negative. So inside will be, change the sign will be x minus 2. So this way, inside of the parentheses, we always start from positive x. This way you can find the same thing to cross cancel more easily, right? So x2 go away, x plus 3 go away. Anything else? That's it. So what do we have? So on the bottom is what? 2. Then negative, we don't leave negative on the bottom. We move out or move to the top, right? Then top would be x plus 2, x minus 1. Multiply straight cross. Is that right? Are we good? So we are learning the section 8.1 and 8.2 for rational expressions. Then to start to operate on them, we learn the basic things first by simplifying. Right? Then we do what? Multiplication and division. So that would be this section 8.1 and 8.2.